Okay, it's pissing down rain at the moment, so there's no riding. So I'm confined to the garage. Now, someone asked me about how I wired it all together, and I'd like to, well, it seems like a good thing if someone's going to try and do this themselves. Now, there were two components to the whole setup. So there was the Woolich one, which is actually just this. So it's got the Euro 5 connector, which is a 6-pin. There's only 4 active pins in it. So power, ground, so yeah, 12 volt ground, and it's a CAN bus. So you only need your CAN high, CAN low signals, and yeah, so that's the extent of Woolich. That's their logger, that's their programming harness for in-bike, not bench. And that's, yeah, effectively all you need from the Woolich part. But if you're going to tune fuel maps, you need AFR. Now, most of the gain from taking your bike to a tuner is just turning off the D-cell fuel cut. It cuts the harsh engine braking and just smooths the bike out. Gives it some good sound because, you know, there's a bit of fuel going in when you engine braking, and it sort of does a little pop and rumble and that. Not loud, but it's a huge difference. So you can just get that or borrow one, except you need the license, and you're good to go. Now the next bit was all the zeitronix stuff, and it came in this box. Okay, came with some stickers as well, whatnot. Now it came with the, and this is my adapter, but it came with the wideband O2 sensor. So round to this particular plug, and sorry for the lighting, but yeah, so I don't know if we can get it, but anyway, it's presumably pretty standard. All right. The main bit was the logger. So what this does is translates the air fuel ratio into a digital signal that goes into there, that port. So Woolich designed this for this logger. They were designed in parallel to some degree, and that happens via this RJ12 cable. Anyway, there's a second output port on here. The O2 sensor here, wideband O2 sensor, connects to this cable here. I don't know why. They probably did it in that one in 2-piece so that you could put an extension through if you needed the extension. But it comes out to this 6-pin socket here, which is in here in the O2 sensor. All right. Now on this side we have this is where the power comes into the unit, and apologies for the lighting, but you know, it is what it is. So this is effectively just a 4-pin mini Molex, I believe. So now 2 pins obviously are power. I've got this all mixed up. So 2 pins are obviously power. The other 2 pins, the purple and the white wires, they allow you, depending upon how you use this, and with the Woolich stuff it's not really appropriate, or really necessary, to connect up this to an O2 sensor connector. I think I have one somewhere, and use it to send a signal back to the ECU. Now if it's sending back a constant signal, the ECU is going to flip out on these bikes. I learnt that the hard way when I was trying to develop my O2 sensor delete. So yeah, it wouldn't really work anyway, so there's no point them shipping that complete. As for power, what they did ship out as an alternative, so this was the Woolich wiring, the zeitronix wiring. They shipped out 2 things. So this is part of the zeitronix kit, is this, all right? Not this, because I made this myself. What Woolich ship out, in addition to the zeitronix kit, is this. So it is intended to plug into the O2 sensor when you remove it, and it had a pass-through, so you can pass through the existing O2 sensor, all right? And the intention was that the existing O2 sensor would stay in place, and you would, where is it? You would install a separate exhaust bung for the wideband O2 sensor on the exhaust you were dealing with. Now, of course, that's a huge effort, and not one I wanted to go into, so we'll get to that later. So, yeah, the idea from Woolich was you plug this in to your existing stock O2 sensor, which I have actually here. This is the one. So, and it will pass, sorry, so I have that here, all right, and it will pass through here and in and out to another connector. Now that other connector I sort of cut off, obviously, because it's not here, and I use that for my first attempts at an O2 sensor delete. But that comes back to this 4-pin mini Molex that connects into here, and the tap here is for the power. Now, it wasn't very practical, and I'll try and show it on the bike later, but yeah, it wasn't very practical for power because these things, these two loggers, are sitting under the seat. Now, the O2 sensor is right up near the radiator, so you're effectively going from under the seat, all right, down to the O2 sensor, all right, but you're also going to where the stock O2 sensor is at the radiator to tap power and come all the way back. And yeah, this wasn't really long enough, and it was kind of annoying, and there wasn't enough room under the radiator cover to stick all of that. And it was just to get power to go from the box here to the from the battery, and the battery and the box are sitting right next to each other under the seat. So it was kind of a overkill to try and get power. You could have just left the O2 sensor in. Mind you, this kit is probably for a lot of different bikes as well. Where the battery isn't as accessible, and it is easier to just route it outside from the O2 sensor and actually tap it from there. But it depends. So what I did was I pulled out the other cabling that they had, and I wired in a switch with just a simple one with on and off, but I also goes to, effectively this is a pass-through, so 2.1mm DC jack, all right, pass-through. Now the reason I did that, and I'll just pause for a sec while I pull all that out. Okay, the reason I did that is because of this. Now this is for LiFePO 4, whatever it is. Can we see it? LiFePO 4, 4S 12 volts, yeah. So that's the BMS, but in here are 4 giant LiFePO cells, DC 2.1mm jack, Anderson for charging and or output, and this thing's great. I made this for camping, and it's double great as a battery tender. Now there's the output on this is reverse voltage protected, and yeah, I can just that's what I use when I'm actually doing the programming, is I connect this in for permanent power, because, well, that can't come undone, can it? So what I do is I plug that into this, and I'll pause for a sec, and that wasn't a pause, that was a stop. So yeah, I plug that into that and I flick that on, and that, all right, supplies the power to this. Now the issue with these is they will drain your battery. both of these together. If you've got them connected, all right, they will drain your battery. They draw that much power. Now so you do need to have some sort of a battery tender handy, yeah, it's just the way it is. Now, so that's why the switch, because I didn't want to have to be connecting and unconnecting. I just wanted to stick my hand under the seat, or pop the seat off and just flick the switch, right, and know that I could just walk away and leave it all connected, because of course it's a pain in the neck to connect it. So that's that. Now the other thing is that, well, obviously if I've made this and I'm using it as a tender on the bike, that you know, I need to still be able to pass through and use it to monitor the battery, or you know, keep the battery topped up. This thing doesn't output a huge amount of current, just because of the way I set it up. The BMS won't let the huge current draw, but I don't need it. You know, the cells can, the cells that are in this thing are nuts. They can output massive amps, probably enough to replace the entire bike battery, but the BMS is there to stop them being abused. But I'll go to the bike, and what we can see here is wired directly in to the battery is 2.1 mil jack. So that's how the whole unit is powered. So I have this anyway. I can it just sits here, seat clears it, and I can charge. I can sort of pull it out, have it plugged in, and then when I want to go for a ride, I just unplug it, push it back in with my finger, and it's out of the way, and go for a ride. Don't even have to take the seat off, only to connect it up. But yeah, that's permanently wired in, all right, permanently there. So that was my source of power. Now in here is this here is the Euro 5 connector, all right. This is your CAN bus, sorry, yeah, the CAN bus ODB port. I'm not going to undo it because it's an absolute mongrel. It's got a little rubber sort of gap on there, and there's a little plastic tab down in there. There it is, that it'll sit on to sort of hold it in place. So yeah, that was how it all connected up. Okay, so on the bike side of it, all right, I've got this in the off position, all right, at the moment. So at the bike side, I just have this plugged, excuse me, at the bike side, I just have it plugged in like that, and that will power it from the battery. So if I turn that on, let's see what we got. We got our green light, all right, and now that's off the battery. So, and that's it. That is the extent of the power wiring. So we have the power wiring, all right, switchable. The zeitronix. We've got our sensor there. Sorry, our data cable to the logger. All right, and then we have that into the Woolich box, and the Woolich box plugs into that connector there. That's really hard to undo, so I'm not going to bother with it at the moment. And that's the extent of the wiring. Now to go over this, the wiring, we have from the battery, all right, through to the power pass-through, through the switch, on-off switch, to the zeitronix logger, to the data out, to the Woolich logger. So we have the cable running up, we have the Woolich logger, all right, and it runs through and into the Euro 5 port tucked down under there, all right, which is I'm not going to do because it's very, very hard to deal with. So that is the extent of the wiring, and that just sits under the seat here. Okay, the next bit is the O2 sensor, and of course this 6-pin mini Molex, or Molex Junior. Okay, now that Molex Junior plug, it connects in to the O2 sensor part here, right? And we have this long piece of cable here. All right, now it of course goes to the O2 sensor that goes down there, and the O2 sensor got an equal length of cable. So for me, I kind of ran it external. I ran it down through here, right, and then I ran it and had it tucked in behind the suspension here, and I had it zip tied to the suspension. I had it tucked under the frame here and zip tied, and then I had it coming out and coming along here, zip tied to here, and then all the excess was basically wrapped around the slider here, and that's the end of it. So apart from that, it was connected into the exhaust. We have here, and I haven't bothered to undo it, the wideband O2 sensor. Now there's a significant difference in the size of the threads. They sell adapters for these, so you can just plug it in to the existing size port. I think this is 18 and this is 12. Don't quote me on that. But yeah, there are adapters you can buy. I'm like, no, I'll just make my own. Because if you have a look at the price of the adapters, they're actually quite expensive for what they are. So I just bought some brass hex stock and machined out my own adapter, and it worked fine. So it did the job, and I had enough brass stock left over to make the plug bung to plug the O2 sensor port when I took out the stock one, which is now living in this box. Now the next thing, the reason I'm sort of doing this video is I was asked to, because someone was asking, should they go and do this, you know, all of this tuning stuff? And the answer I'd say, and we kind of talked about it, and it was like, well, it's no. Is there value for the average person to do this? No. We all think there is. You ask, hey, I've put a new exhaust on, do I need a tune? You ask that on Reddit or Facebook, and you will have every single person, well, you know, you'll have everyone but me and maybe one or two other smart people say, yes, you must have a tune. And it's like, it is utter bullshit. And, you know, it's crazy that people say it. Just out of, like, mind-blowingly crazy that people say you must have a tune. The reality is, if you have the O2 sensor, the actual stock O2 sensor connected to the bike and connected to the ECU on that new exhaust, then the bike will tune the AFR using its learning algorithm. There's a whole reason where if you disconnect the O2 sensor, the bike starts throwing all sorts of different error codes. They're all to do with learning algorithm. Like when I was doing the O2 sensor delete, the huge eye-opener for me was when I had it outputting whatever voltage it was. I think it's exactly half a volt, and it was just half a volt steady. It was just boom, half a volt steady. And so that was telling it, hey, it's all in tune. And the bike said, this value is not changing. There's something wrong, you know. And it was like, that's it. It expects it to change. It is learning. It is very, very active with what it's doing. So the reality is, you don't need a tune, right? The bike, the O2 sensor feedback loop that is in the bike, the tuners, you know, disable because, well, they want to use their custom maps, but you don't need to do that. The bike is constantly tuning the AFR, all right? So the stock maps, the maps that come in those never get used. They're a starting point for the O2 sensor learning algorithm. When the O2 sensor learning algorithm's done its thing, the ECU isn't using that stock map, all right? The only time the ECU uses the maps that are flashed to it is when you disable the O2 sensor feedback loop, which tuners do. That's one of the things we do. And then, you know, when we program it through this, and then the fuel map it's using is our one. At the moment, this one is tuned, whatever it is, about 13.5 or 13.7 AFR for most of the range. It is tuned for 95 RON here in Australia, Yeah, you don't need it. You don't need to do this. I did this because I thought I did. You know, I believed all those people on the internet that said, oh yes, you must do it because now that you've modified your exhaust, it's going to be lean, you know, because you've increased the flow. And it was like, that's complete bullshit, because the O2 sensor buddy adapts to it anyway. You know, the whole O2 sensor feedback loop adapts to that new exhaust. The only time you need a tune is if the new exhaust does not allow you to install the stock O2 sensor. That is the only time you need a tune, you know. So, and the bike will tune itself and the performance is good, you know. There's no real performance difference between the a mapped AFR and the auto self-learning. You don't need to do this. I mean, what gains did I get? I'm a bit of a nerd. So I'm a data nerd, I'm a software developer, all right, I'm into electronics. So for me, you know, I did it because I thought I had to, and in the end the reward was just, well, it was one of my hobbies. You know, it fitted in with what I do, all right? But for the average person who doesn't have an electronics background, doesn't have a software background, you know, isn't a bit of a data nut, then this is going to be more trouble than it's worth, all right? But if you want to do it, you know. But it's, I mean, this is $1,100 Australian, so it's a lot of money, all right? A lot of money to spend on a hobby. I mean, mind you, then we buy bikes that have, you know, $500 for a pair of tires that last, you know, not that long. But at the same time, yeah, you got to choose where to put your money, and not everyone can blow that. And this rain has just gotten so bad at the moment that I'm going to have to shut up because I can barely hear myself talk. But, you know, thanks for being along.